This is a tutorial video for GCSE Combined Science and GCSE Physics, looking at current and change from the electricity topic. By the end of this video, you should be able to state what is meant by current, describe how to measure current, calculate charge flow based on current, calculate current based on charge flow, and finally describe the behaviour of current in both series and parallel circuits. When we talk about current in the context of electricity, we mean the flow of charged particles. Usually electrons, but it could be other charged particles like ions as well. Current is a measure of speed. How fast are those charged particles flowing? And we measure it using a piece of equipment called an ammeter. When you use an ammeter, it needs to be placed in series with the other components. In other words, it needs to be part of the same circuit. That ammeter measures the speed of charged particles as they travel around the circuit. We can calculate the number of charged particles passing a particular point within a given time frame using the 15th equation from the GCSE Physics equation sheet 1. That's the list of the 21 equations that you need to memorise for the exams. The shorthand for this equation is Q equals I times T, where Q means something like quantity of electrons or quantity of electricity, and I comes from the French term which means intensity of current. The units for these are coulombs for charge, amperes or amps for current, and seconds for time. It's really important before you complete any calculations that you make sure the numbers you've been given in the question are expressed using these units. If you had, say, a time that was expressed in minutes, you'd need to convert it before you did the calculation, otherwise you'd get the wrong answer. Let's practice substituting some numbers into this equation. A current of 5 amps flows for 60 seconds. Now I know that the 5 is the current because it has an A after it standing for amps, and amps is the measure of current. So I can put that 5 there. Seconds obviously is a time, so I can put 60 into the right place as well. And now I'm doing 5 times 60 to give me an answer of 300 coulombs. Hopefully you were able to calculate that 3 times 420 is 1,260 coulombs, 0.2 times 50 is 10 coulombs, 0.8 times 120 is 96 coulombs, and 0.1 amps flowing for 900 seconds will transfer 90 coulombs of charge. As we already mentioned, it's really important that before you complete any calculations, you check that all of the numbers are expressed using the appropriate units. If you don't do this, then even if you do the calculation correctly, you'll get the wrong answer. Pause the video here and see if you can work out what these numbers are, expressed correctly in seconds and in amps. As you know, there are 60 seconds in a minute, so to convert minutes to seconds, we times by 60, which for the first one gives us an answer of just 60, and for the second question gives us an answer of 300. There are 60 seconds in a minute and 60 minutes in an hour. That's a total of 3,600 seconds in an hour. So 1 hour is 3,600 seconds, and half an hour is 1,800 seconds. To convert from days to seconds, we need to know that there are 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. So that gives us a total of 86,400 seconds in one day. You should be able to apply the prefixes milli, micro and nano to any of the units that you meet anywhere in GCSE Science. It's just as reasonable for us to have millilitres or millimetres as it is to have milliamps. To convert milli to not milli, I guess, you need to divide by 1,000. So that means that 100 milliamps is 0.1 amp and 20 milliamps is 0.02 amps. A microamp is 1,000 times smaller than a milliamp, so now you need to divide by a million. So we get 0.0004 amps and 0.00003 amps. A nanoamp is 1,000 times smaller again, so now you need to be dividing by 10 to the 9, giving us an answer of 1.5 times 10 to the minus 8 amps. Here are some more questions for you to have a go at, but in these ones you need to watch out for the units and make sure that all of the numbers are expressed in standard international units before you complete the calculation. Pause the video and when you're ready we'll go through the answers. In this first question, we need to convert the current from 500 milliamps to 0.5 amps. Then 0.5 times by 60 gives us an answer of 30 coulombs. In the second question, it's the time that needs converting. 3 minutes is 180 seconds, and that gives us a charge of 54 coulombs. In question number 3, it's the minutes that need converting again to 300 seconds, so that's 450 coulombs. In question 4, we need to convert both parts, so 800 milliamps is 0.8 amps, and 12 minutes is 720 seconds. If you multiply those together, you get 576 coulombs. Finally, we know that 1 hour is 3,600 seconds, so that gives us a charge of 360 coulombs. As with every equation in GCSE Physics, you need to be able to rearrange this one in order to make something else the subject. In this question, we're going to ask what the current is if a given charge passes a point in a given amount of time. So in order to make I the subject, we need to get rid of that t. Right now, I is multiplied by t. So to undo that multiplication, we need to divide. And whatever we do to the right side, we do to the left. So we divide both sides of this equation by t, and we're left with Q over T is I. In other words, current is the amount of charge divided by the time it took for that charge to flow. So now we have a question to calculate the current when 840 coulombs of charge flow in 7 minutes. Remember, 7 minutes is no good to me. We need it to be in seconds first. So 7 minutes is 420 seconds, and then 840 divided by 420 gives me a current of 2 amps. Here's one final opportunity for you to practice with this equation. I've given you the rearranged version of the equation in the top right, and we'll do one worked example together before you go on your own. So firstly, we need to recognise that 10 minutes needs converting, so that's going to be 600 seconds. Then Q divided by T is 450 divided by 600. That gives me an answer of 0.75 amps. Pause the video now and do the remaining 5 questions on your own. When 81 coulombs flows in 45 seconds, that's 1.8 amps. When 300 coulombs flows in 2 minutes, I need to convert 2 minutes to be 120 seconds and do 300 divided by 120, which is 2.5 amps. For question 3, you should have 3.2 amps. For question 4, 0.9 amps. And for question 5, 1.7 amps. How did you get on? You also need to be able to describe the behaviour of current in series and parallel circuits. In a series circuit like this first one, the current is the same everywhere in the circuit. So that means that if the reading on this first ammeter is 3 amps, the reading on the second ammeter will also be 3 amps. This makes sense if you think about what current actually is. It's a measure of the speed of the flow of charge. A certain number of charged particles are going to pass this first ammeter every second. In a series circuit, there's only one loop. There's only one path for them to take. So the same number of charged particles will also pass the second ammeter in a second. And that means that the speed is the same, and that means that the current is the same. It's a slightly different story in a parallel circuit. A certain amount of charge will pass this ammeter each second. Let's say that again the reading is 3 amps. But this time there's a node, and some of the charged particles will go this way, while some of them will go this way. This means that the current in a parallel circuit is going to split along the branches. The exact split will depend upon the resistance of those branches, and we'll worry about that another time. But the important thing is that the branches still must add up. So if this ammeter reads 2 amps, then this one must read 1 amp. Or if this one read half an amp, then this one would need to read 2.5 amps. Whatever their readings, they must add up to be the same as the original ammeter. And when the branches join back up again on this right hand side of the circuit, again we would see a reading of 3 amps. Thank you very much for watching, and I hope you're now feeling confident about calculations involving charge and current. If you are, then let me know in the comments below, and don't forget to like and subscribe for more GCSE Physics videos coming soon.